today about the difference between the quantity and quality of soil organic matter in Mediterranean agroecosystems. Well, the soil organic matter is the largest pool of organic carbon on the Earth's surface, amounting to more than a half part of total carbon. Soil organic matter is involved in the most soil-specific chemical and biological processes. And nowadays, the problem is not what is considered as carbon sink, that is very rare, but the assessment of mean residence time of soil organic carbon in different compartments. In general, the first plant biomass is stored for days to years. On the other side, the recalcitrant organic carbon may remain for several centuries. Then the soil organic carbon sequestration is the result of a series of processes which the carbon dioxide in the atmosphere is removed into the biochemical cycle and then accumulated in the soil. The soil organic carbon sequestration has both positive and negative side effects. Between the positive side effects, apart from reducing the greenhouse effect, soil carbon sequestration leads to additional benefits in terms of sustainability productivity. These benefits are the improvement of soil structural stability, the water holding capacity, the continuous release of farm nutrients, and the biological activity, and increase the productivity. And the soil organic matter plays a role in as an environmental filter, regulating the mobility of pollutants such as agrochemicals or heavy metals. Then, on the negative side, the stabilization of soil organic carbon is connected with the fact that, in addition to carbon, other bioelements such as nitrogen, phosphorus, and sulfur can be accumulated in the soil, reducing the productivity in the crop. In other words, in a global management policy, it will be more important to monitor the quality rather than the total quantity of the organic matter sequestered in the soils. Well, the soil organic matter is composed of a mixture of organic macromolecules with a chaotic structure in which it's not possible to establish regular structural models. Then, in the laboratory, the concentration of soil organic matter is often evaluated by partial oxidation methods with a potassium dichromate. But the quality is here defined as the extent to which plant and microbial debris are transformed in soil in humic substances. Then the quality of soil organic matter can be evaluated in terms of the molecular characteristic of humic acid. After to isolate the free organic matter, the extraction of humic substances is carried out. The humic acid is referred to as the alkali soluble and acid insoluble organic fractions. Then we can the total amount of social organic matter referred to as the percentage of the different fraction of particulate as free organic matter or colloidal in humic or fulvic acid. Then, concerning to the quality, the easiest way to evaluate the soil organic matter is to measure the color of the humic acid previously extracted. When the color is very dark, the quality is high. In the most favorable case, the assessment of soil carbon stabilization can be carried out by using specific techniques of isolate and analyze of biomarkers or signature compounds occurring in the humic substances. For example, we can identify biomarkers from fungal activity or different biomass type or microbial activity, or for example, the effect of fire can be identified for these constituents. For example, if we use the analytic pyrolysis, we obtain a series of family of compounds. For example, metoxic phenols are biomarked from plant vascular biomass, and these compounds can be used to evaluate the degree of the decompositions of the soil organic matter. By contrast, the alkyl compounds can be used to identify different microbial communities. For example, using the fatty acids, the different fatty acids. Alternatively, non-destructive methods such as visible, infrared, including nuclear magnetic resonance spectroscopies, are available. In this graph, we can see a gradient from infrared spectra, where we can identify some ecosystem where the lignin is accumulated in the soil, and others where the lignin is not present. Most classical studies have described the humic acid fraction, which has complex origin and structure varying in terms of the vegetation type, climatic condition, geological materials, and human management. In this context, the semi-arid Mediterranean regions illustrate this situation. Here, the amount of soil organic matter is very, very low. It's low concentration. No? Values are the mean values are low, less than 1%. However, the quality is very high, showing high resilience to possible future climate change. The above situation is marked contrast with the soil formation in the Mora forest. Here, there is a large amount of weakly transformed soil organic matter. With the possible rise in global temperature, this forest could turn into active C dioxide source as a red focus or red point, because the weak association between the organic matter and the mineral fraction. The biochemical pathway of soil organic carbon sequestration are still imperfectly known. There are few experimental data concerning the mechanisms responsible for the stability of the soil organic matter. There are two main mechanisms, the indirect or the direct processes. In particular, there is not sufficient literature, and controversial results exist about the value of laboratory incubation experiments to assess the resistance against biodegradation or quality of the soil. There are two review published in Nature, where the results are very controversial. Well, it's clear that the performance of the world carbon sequestration process depend on the soil type and the different compartments, but it's more intense when the abiotic and biotic factors occur simultaneously. For this reason, main studies of the potential of the soil as carbon sink as report for different bioclimatic regions and in soils developed on different geological substrates provide a wide range of results so that the topic remains controversial. Although carbon stabilization mechanisms are still imperfectly known, a series of pathways have been suggested. For example, the selective preservation of biomass into aggregates, where diffusion of soil enzymes is largely hampered, and where it is possible to identify compounds occurring in the biomass, the plant biomass. Then accumulation of substances which are highly recalcitrant, for example, from fire forest. And on the other hand, we can identify the insolubilization of precursors of soil organic matters through microbial, enzymatic, or abiotic blend. Then in forests, the selective preservation of biomass into aggregates has been identified as the frequent mechanism. We can obtain a lignin signature where we can identify methoxyphenols compounds. In other ecosystems, for example in volcanic ash soils, the process dominant is the insolubilization of precursors of low molecular weights with short-range minerals like alphantite or goethite. No? In these soils, we can identify carbohydrate and nitrogen compounds and fungal pigments as the main biomarkers. Finally, in the Mediterranean agroecosystems, accumulation of the substances which are highly recalcitrant of type alkyl compounds have been identified as the main carbon stabilization mechanisms. Here, both the abundance of carbonate and the particular climatic condition may play a role in enhancing the linking of organic and mineral fractions. In conclusions, quantity and quality of soil organic matter is not the same. The concentration of soil organic matter is evaluated often by a partial oxidation method with potassium dichromate, but however, the soil organic matter quality is here defined at the extent to which plant and microbial debris are transformed in soil humic substances. The assessment of soil organic matter quality can be carried out by using specific techniques such as analytical pyrolysis or spectroscopy method, and a series of biomarkers or signature compounds are identified in the lipid or the humic acid fractions. Now, the mechanisms of soil carbon stabilization are needed to understand why some soils, or some Mediterranean soils, store more carbon than others. In Mediterranean agroecosystems, although the soil organic matter is in low concentration, less than 1%, it is of high quality, showing a high resilience to possible future climatic change.
You are talking about the negative and the positive
effects of the carbon sequestration.
Organic carbon, yes. I couldn't catch the point of this negative effect of the organic carbon.
Okay, when the carbon sequestration is connected with the fact that with the carbon, other bioelements are sequestered, nitrogen, phosphorus, and sulfur. And this decrease the enzymatic activity and reduce the productivity in the crop. This is the
negative, it's like reducing only.
Reducing. See, the negative effect of the carbon sequestration is that other bioelements are sequestered and the field is reduced. The crop could be reduced, depending on the soil type. This is referred to as nitrogen handling. Handling is a process in which there is nitrogen, but it is not available for the plants or the roots.
So it's the same, phosphorus or...
It's the same, phosphorus, sulfur and
they are
nitrogen.
in soil, but they're not available for the plant.
The same,
Do you know what is the
advantage to analyze by pyrolysis method or by spectral?
Analytical pyrolysis is a degradative method where the soil sample is broken in the different constituents, but the spectroscopy methods are not destructive, and the soil sample is not broken. It's not. It's not. There are methods not destructive, and the information is more global. For example, when we did infrared spectroscopy in a soil sample, we obtained a fingerprinted, where we cannot identify signature compounds, only the fingerprinted. But the analytical pyrolysis is possible identify to molecular compounds. But
analytical pyrolysis is not. In Spain, I only know in Sevilla that they are made.
Sevilla, Galicia.
Okay, because I want to do now, but I was thinking of doing it. I don't know very well what method is better.
But the problem with the pyrolysis is that the person have a high degree of preparation to identify the compounds.
I don't know if you know Nika from Sevilla.
Yes.
He's doing
yes.
With pyrolysis, you identify all the compounds and the spectrometer you only identify a thick humic
No, first you must isolate the humic substances. When you isolate the humic substances, you can extract the humic acid, that is the alkali soluble organic fraction. Then the humic acid is purified, and then you can use different techniques to study the humic acid, previously extracted humic acid fractions.
Thank you.
One more question. If you have a very organic matter-rich soil and it's has a negative effect because of the nutrient retention, what do you think that, for example, with mycorrhiza you can mitigate this effect?
Yes, for example, if you have a soil with high of nitrogen, you can use sugar. For example, to increase the microbial activity, improve the mobility of the nutrients, and the nitrogen is easily reduced, and the plant can obtain the nutrients.